Hello, good afternoon, my dear students. Welcome to one more amazing session from Sri Chaitanya Academy. How are you all doing? And we are in Nirmaan 1.0 session, and today's class all about chemical bonding and the most important topic that you are going to see, the dipole moment. So, how your NEET examination preparation is going on? We already started NEET 2027 preparation. So, we started from stoichiometry, chemical bonding and atomic structure, periodic classification, and hydrocarbons also we completed, alkane, alkene and alkyne. And we are going to discuss various levels of topics on a fragmented basis. So, in the chemical bonding, we could discuss the entire chemical bonding as a marathon, but has no impact because the NEET examination nowadays is coming as a multi-concepted version. That's the reason why the previous class we discussed about the hydrogen bonding, and in this class dipole moment, and some other class talking about the hybridization and VSEPR theory and molecular orbital theory. Like that we are going to subdivide the various topics. So, my dear students, look at this. What is the meaning of dipole moment here? So, in this dipole moment in the chemistry, so the polarity of bond means here, let us say carbon, hydrogen and chlorine. Chlorine is more electronegative, so that shared pair of electron is moved towards this chlorine. Therefore, chlorine will get partial negative charge and you are going to get a partial positive charge. And because of this, you are going to get two poles, a positive pole and negative pole, by the movement of the bond. So, it is said to be bond movement, and rises to existence of two poles is called as a dipole, and this is called as the dipole moment, and the dipole moment is mentioned with mu, and it is the distance product between distance of two atoms which is in bonding and the charge. And you can see this is going to be ESU centimeters is the unit, and otherwise d by is the unit. 1 d by is equal to 10 power negative 18 ESU centimeters. And let us see here the commonly used units and charges. You can see you have one charge unit of electron can be 4.8 into 10 power negative 18 10 power minus 10 ESU electrostatic unit, or 1.6 into 10 power negative 19 coulombs. So, the charge, it is in SI units and it is in CGS units. And I want to say here, so value of the dipole moment is going to be charge into the distance of separation of charges, and it is given as in SI units. Let this Q is, okay, let this distance is in 1 angstrom units, and the charge is going to be 4.8 into 10 power negative 10. You are going to see the dipole moment as 1 into 10 power negative 18 ESU centimeter, and you can also say a 1 d by. So, it is going to be 1, so dipole moment is a 4.8 d by, you can say. So, the values of E can be calculated in various versions, and distance the same way you can take this as, okay. So, I just want to say the direction of the dipole moment, simple trick for your NEET examination. I want to say dipole moment is indicated with arrow mark with the tail cut. Always show this arrow mark towards most electronegative atom. Dipole moment is a vector quantity. I want to say A is an element with B is the bond and C is the bond, and the separation is going to be theta, and this bond moment is mu1 and this bond moment is mu2. The resultant, hi Chaudhary, good afternoon, good afternoon. Those students who are online, happy Raksha Bandhan greetings from my side, Infinity Land Sri Chaitanya Academy YouTube channel. Okay, God bless you all. Here resultant dipole moment is going to be root over nu 1 square plus nu 2 square plus 2 nu 1 nu 2 cos theta. So this is what the resultant dipole moment. If the resultant dipole moment is a 0, you can say the molecule is a non-polar. The resultant dipole moment is not equal to 0, you can say the molecule is polar. Are you getting or not? So look at this ammonia. Nitrogen is more electronegative. Take this arrow in this way. So the resultant dipole moment in this way. Bhaskar, now carbon is more electronegative, okay, and you can see the dipole moment appears like this. Resultant dipole moment is going to be 0. Sulfur dioxide, you are going to see resultant dipole moment is not equal to 0, a polar molecule. Carbon dioxide is exactly opposing two bond movements, so it is going to be 0. Fine. That's good explanation. Okay, so dear children, if you have any doubts during the live session, you can directly ask the questions in the live session, and if you are watching the recording, if you have a doubt, you can mention in the comment box, and also if you want any topics to be explained, you please mention in the live or comment box, not a matter at all. And please, those who are online, please like the session, share with your friends, and subscribe to Sri Chaitanya Academy Infinity Learn NEET YouTube channel. So, bacho, Bhaskar, now let us see some more question. What is the shape of SF4? See, sa shape. Shalu Kumari, hi, happy Raksha Bandhan. It is going to be, dipole moment will be like this, okay, resultant dipole moment is not equal to 0, right? Simple trick, hi Palak. Simple trick, take the arrow mark towards the more electronegative atom, right? That's good. XeF4 square planar molecule. In this square planar molecule, you are going to see the bond movement is getting cancelled, so it is going to be 0. Now, XeF2 linear molecule, both bond movements get cancelled, dipole moment is going to be 0. Okay, okay, my NEET is clear, that's good. So you attended my classes on the YouTube channel and a clear NEET examination, congratulations. So XeF4, could you tell me whether it is a dipole moment is 0 or not equal to 0? 0 or not equal to 0? Look at this, it's cancelled, it is cancelled, and it is cancelled, but the resultant dipole moment will be there. So resultant dipole moment is not equal to 0, it's a polar molecule, right? It's a polar molecule. That's good. So some important orders to remember here. I want to say the polarity of hydrogen halides. You can see hydrogen iodide, hydrogen bromide, hydrogen chloride, hydrogen fluoride. So I mean to say the dipole moment is directly proportional to the electronegativity of fluorine, chlorine, bromine and iodine. So that HF 1.78, so the electrons are pulled more towards the fluorine. So chlorine, HCl, HBr, HI. Any doubts? Similarly, one more thing I want to say here, very, very important for NEET aspect. Okay, so look at this. Ammonia and NF3 like this. In ammonia, you are going to see the nitrogen and then nitrogen to hydrogen bond, and the lone pair is also having the bond moment. So while the lone pair movement in this direction opposing this nitrogen to fluorine bond movement. So I mean to say there is a opposing forces, so that I want to say resultant dipole moment of NH3 is always greater than resultant dipole moment of NF3. That's very important. So that can be, a question can be neat, which of the following statements are true, which of the following statement is not true, kind of things can be asked, right? बच्चों अगर कुछ डाउट है ना तो आप चार्ट बॉक्स में पूछना. Hi Shalu and Bhaskar Divakar, any doubt? Now moving ahead, some important points. So the dipole moment, that is a fluoroform and it is going to be a chloroform, and the dipole moment you have to compare, fluoroform is going to be 1.81 dBi and the chloroform 1.87 dBi. Why so? Because of the lone pair of electrons present on the fluorine, there is a slight repulsion. That's the reason why the bond is pulled towards this, and of course there is a back bonding kind of concept also we can discuss here, right? So this pointer is very important in the NEET examination. Resultant dipole moment of CHF3 and the resultant dipole moment of CHCl3. So CHCl3 is greater, slightly greater. Do you know this point? Actually it is given in the NCERT as a just value, but in the NEET examination nobody focus on this micro level discussions. Yeah, it's an important question. Meera Jair, hope you like this point. It's a super important point. Okay, and we'll go some more details about this. Chloroform and dichloromethane and methyl chloride. Mirozar, I told you now, right? That's good. I have taken your new name. Anybody who is there online and talking to me and chatting with me, I am going to take your name. Okay, now if you say this CHCl3, CH2Cl2 and methyl chloride, dichloromethane and trichloromethane, the dipole moment of this methyl chloride is greater than dichloromethane is greater than chloroform. Of course, carbon tetrachloride CCl4 is going to be, dipole moment is going to be 0 here, and this order is also very important. You read in class 10th by subject, study NEET. Of course, that's a great approach. Okay, students, fine, doing great, and this is also very important. So give me a thumbs up and fire emoji, and those who are online, please like the session, share with your friends and subscribe to Sri Chaitanya Academy Infinity Lane NEET YouTube channel. So when you subscribe and आगे आने वाले के जो सेशंस होते हैं आपको तुरंत आपको नोटिफिकेशन मिल जाएगा. Okay, now I want to say some important orders. Look at this. As I said, NH3 dipole moment 1.470 by N F3. This is a fluorine, dear. This is a fluorine. Why? The lone pair, and this direction is also given wrong here. Okay, so the lone pair of electron opposing the bond movement that we already, thank you very much, and you can see CH3F, CD3F. so isotope is given here, CD3F and CH3F. So the bond moment of the deuterium, so CH3F 1.847 and here 1.857 dpi. So heavier isotope is going to create more dipole moment. Okay, so the dipole moment in this direction. So NEET examination, this traction is important, dear children, this traction is important. And also dipole moment and the percentage of ionic character. Dipole moment and the percentage of ionic character. So due to dipole moment, you are going to get a little bit positive charge and negative charge. As a result of, yes, what is this ABCDF? again. So a covalent compound is a bond formed by the mutual sharing of electrons. But what will happen? Due to electronegativity difference, it is getting a little bit partial charge and partial positive charge and partial negative charge, right? As a result of this, the dipole moment makes it is little polar. Because of its little polar, it has a little bit of ionic character, and that ionic character can be calculated by using this. Percentage of ionic character is equal to observed dipole moment upon theoretical dipole moment into 100. And you can calculate this dipole moment percentage of ionic character simply. I will give you an example as well. Miraj Aur, I have taken your name. Okay, you keep shouting, I'll take your name. Whenever you have a doubt, please ask us. Okay, Miraj Aur, you're from? And let us talk about here observed dipole moment, experimental dipole moment. ये दोनों का क्या फर्क पड़ता? Observed dipole moment and theoretical dipole moment. And observed dipole moment means you do some experiment and you observe the value, that is experimental value examination में दिया जाएगा. Voila, it will be given in the exam. You are from Kashmir, lovely. And the theoretical dipole moment mean to say considered to be 100% ionic in nature, and that can be calculated. Mu is equal to distance and charge. You can do this. You have to calculate. Okay, nice. I love Kashmir, and definitely we will meet at Kashmir. Okay, okay, come on. So based on this, you can calculate percentage of ionic character in the covalent bond. Definitely you can see percentage of ionic character. Haney-Smith equation. This is Haney-Smith equation. That is equal to 16 into electronegativity difference between two atoms plus 3.5 into electronegativity difference between two atoms square. That will be given as a percentage. Yes. Thank you very much, Mira Ujair. Okay. If I am wrongly pronouncing your name, please excuse me. Okay, that's good. That's good. If somebody is starting in the live class, the session का जोश भी बढ़ जाता. Right. So आज के topic भी ऐसे है बेटा. Dipole moment. So I request those students who are online, you pick from your choices given to you, pick your micro concepts just like this in today's class and mention in the comment box or in the live chat. So अगले आने वाले के सेशन में वो टॉपिक उठा के आपको पूरा एक्सप्लेनेशन देना चाहता हूँ. Yeah, that's good. That's good. So I will give you the best explanation for that. बच्चों, now let us see. So here gives only approximate values of the percentage of ionic character. In that way, you can have an explanation various types of intermolecular forces. Okay. So you have ion dipole attraction. So when sodium chloride is dissolved in the water, NaCl is dissolved in the water. So what will happen? Na plus and Cl minus will be there. Okay, that's an ion. Na plus is an ion now. Now water molecules are going to surround around it. You can see a beautiful animation. All the water molecules are going to surround. The dipole of the water is surrounding the sodium plus. So this is called ion dipole interactions. स्पीक इन हिंदी आज हमारा सेशन में ओके ये इंग्लिश में जाना है, आधा हिंदी आधा इंग्लिश. ओके, आर यू गेटिंग और नॉट बेट? मेरा जोर, कम ऑन. सो आयन डाइपोल इंटरेक्शन का मतलब आयन एंड डाइपोल ऑफ द वाटर बीच में अट्रैक्शन फोर्सेस होता है. सो NaCl, Na and Cl. So Na plus oxygen O minus, you see oxygen and hydrogen. O minus is a negative charge, H plus is a positive charge. ये O minus का साथ इसका जुड़ाई हो जाएगा, है ना. Now if you see the Cl minus, so again oxygen and hydrogen, you are going to partial negative charge and partial positive charge. This partial positive charge of the water molecule is going to be, thank you very much, thank you very much, very much. And you see the positive charge of the hydrogen is making an interaction with Cl minus. Are you getting or not clear? So really I'm enjoying the session because the students is talking to me. It's not a radio session, it is a live interactive session. Okay, so let's speak more interactive sessions like this. You please mention whatever the topics you want. Okay, come on, let's talk about the dipole attractions. फिलहाल आयन डाइपोल अट्रैक्शन के बारे में देखा, अभी तो देखने वाले हैं आयन डाइपोल अट्रैक्शन. व्हाट इज द मीनिंग ऑफ डाइपोल अट्रैक्शन? मान के चलो HCl है, हाइड्रोजन क्लोराइड, क्लोरीन का नेगेटिव चार्ज है एंड हाइड्रोजन का पॉजिटिव चार्ज है. बगल वाले का जो मॉलिक्यूल है ना HCl, H plus and Cl minus. So the partial negative charge of the chlorine, partial positive charge of the hydrogen of the adjacent molecule, दोनों के बीच में थोड़ा attraction forces होता है. That is what is called dipole attraction. समझ में आ रही है बेटा? That's good मेरा जोर. That's a fantastic one. And आगे बढ़ना है तो थोड़ा सा, and I want to say this is an attraction. So wanted to say here, this ion dipole attraction exists between the positively charged end of a molecule, and this is a permanent dipole. दो permanent dipole को बीच में होना है. सूर्य प्रताप, why is the dipole moment of NH3 is greater than that of NF3 even though fluorine is more electronegative? सूर्य प्रताप, and I already explained that, आपके लिए और एक बार explain करना चाहता हूँ. And hydrogen and hydrogen and hydrogen, you can see nitrogen, you are going to see the fluorine. Now if you see the electronegativity of the nitrogen is more, okay, and the lone pair is also in this direction. Okay, Mirazor. Now this lone pair of electron in the NF3 and this is in the opposite side and the lone pair moment is opposing. So that little bit force is cancelled here. That is the reason why I just wanted to say dipole moment of NH3, dipole moment of NF3. It is going to be in this way. Surya Pratap, yes or no? A thumbs up and like the session. You did not like the session. Those who are online, please like the session, share with your friends. Okay. Now moving ahead, I just want to say attraction forces as well as repulsion forces will be there among the dipoles. So it is a HCl molecule, HCl molecule, HCl molecule, HCl molecule. Between that, attraction forces as well as repulsion forces are there. These are the magnitude of the intermolecular forces. You have to study. Chemistry is the study of matter. In that study of matter, matter is made up of atoms and molecules. There is an attraction and repulsion forces among the molecules. We are studying that because of the little charges on the tiny atoms are seen. Understand? Clear? Hope everybody enjoying the session. Dear children, that's good. Now let's talk about ion-induced dipole attraction. Ion-induced dipole. That will happen between an ion and a non-polar molecule. Say an example, it is a non-polar molecule and it is an ion. So when this ion is approaching that non-polar molecule, little bit charge can be produced, that is a dipole is being induced. Are you getting or not? Are you getting or not? Clear? That's why I say ion dipole induced. So you want me to take some more classes like this? I'll take. Beautiful presentation. Beautiful presentation. Right? Now let us see one more. So this is dipole and it is a non-polar. So dipole, induced dipole attractions will be there. That is what? Dipole, induced dipole. So this is otherwise called Debye forces. Bachcho. Done. Very good. So जब ये पॉजिटिव और नेगेटिव पोल ए नॉन पोलर का मॉलिक्यूल के सामने आएंगे तो इसका इंडक्शन के हिसाब से इसका थोड़ा सा पोलैरिटी मिल जाएगा. देखो यू कैन सी देयर इज अ डाइपोल, तभी इसका दोनों का बीच में अट्रैक्शन हो जाएगा. भास्कर, आर यू गेटिंग और नॉट? मेरा जोर, एनी डाउट्स? एनी डाउट? एंड और एक चीज है, लंडन डिस्पर्शन फोर्सेस कम से कम फोर्सेस, कम से कम एनर्जी वाला है. यू कैन से solubility of noble gases in water. Yes, maybe 1 or 2 mole noble gases may be soluble, but the solubility is ion. This is a dipole, induced dipole forces is an example for this. And talking about London dispersion forces, size of the noble gas increases, polarizability increases, so the dipole induced dipole forces increases and the solubility in the water increases. That's the reason why the solubility of helium is less than neon, argon, krypton, xenon, like that. Yes, P, we can connect this in the terms of p block elements as well. Now Mirazor, I am coming to that. Okay, अगर साइज बढ़ जाते हैं तो इन पोलराइजेबिलिटी बढ़ जाता है and dipole induced dipole forces B increase होना चाहिए. That is the reason why solubility of the gases, noble gases, increases as the size increases. And at last it is a London dispersion force. The time is also very important. That's the reason why quickly I just want to finish this. If two molecules are non-polar, so a खुद dipole induce कर सकता है instantaneously. That is called a dipole, London dispersion force. Okay, instantaneous dipole induced dipole forces, you can see it is purely a non-polar molecule. It's a purely non-polar molecule. Okay, so now what will happen? This molecule temporarily induces dipole, so that the other molecule also temporarily induces dipole. So that is called temporary induced dipole forces, is also called as chiasm forces, is also called as chiasm forces. That is called London dispersion forces. So strength of the London forces, as the size increases, intermolecular force increases and the London dispersion force increases. So London dispersion force, iodine is maximum. That's the reason why fluorine and chlorine are the gases, bromine is a liquid and iodine is a solid. Okay, and we will meet with more stuff in the next class. So we have enough time and we'll be discussing all these things. Okay, keep learning. Thank you very much and happy Raksha Bandhan. Thank you very much and we'll meet with more stuff in the next class. Thank you very much. Please Those who are online, please like the session, share with your friends, subscribe to Sri Chaitanya Academy, Infinity Learn, NEET YouTube channel. Thank you very much. ఇప్పుడే 5 minutes వస్తాను. ఎంతమంది వచ్చారు? 716 అంటే ఇంకా పెరుగుద్ది రాత్రికి.